All right, everybody, we're going to get started. Other people show up, they'll have to catch up as they can. Welcome again to another session of our Virtual Tech Exchange webinar series. This time we are very fortunate to have both Jeff Tenenbaum and Tim Olson from IBM with us to talk about the IBM Blockchain Platform and the solutions that they've been working on using the IBM configurations. Just keep a couple notes. There is a Q&A at the bottom of your screen. You can use that to throw questions at me, and I will keep track of them. So at the end of the session, we will go back to them and we'll see how many we can answer in the time we have. There is also a poll on the polling button if you want to take that sometime during the session as well. That would be appreciated. And if there's a chat, you can throw that too. All right, so let's go ahead and dive in. I'm going to throw it over to Jeff Tenenbaum of IBM for him to get started.
Thank you so much. All right, so I'm just going to share my desktop. Hopefully everyone can see it now. So would that be a yes?
I can see it fine, Jeff.
Fantastic. Okay. Then we will get started. I wanted to, first of all, thank ESS for inviting Tim and I to speak to you a little bit. We're going to kind of cover our IBM Blockchain Platform. With myself, again, is Tim Olson, who is a distinguished IT architect with IBM. So very excited. And also, he's going to talk to us about some cross-domain use case information. So why don't we go and get started? So we're going to cover three key areas. I'm going to touch on some permission blockchain fundamentals, just kind of review that for those of you that may not be that familiar with some of the ideas that are unique to permission blockchain technology. Tim is going to touch on, again, blockchain for multi-domain, and then I'm going to jump into our actual IBM blockchain platform and provide you with a short demo. Again, my sincere thanks to ESS for giving us the opportunity to chat with you guys today. So with that being said, let's jump into it. So Maersk did a study back in 2016, and Maersk is the leading player in the ocean shipping industry. But Maersk did a study, and the results of the study were pretty interesting. They found that for shipment of a single container on one of these ocean carriers, and you can have up to 20,000 of these containers, but just for a single container, you could have up to 200 separate transactions or interactions that would occur with up to 30 different organizations. And they found that there were some challenges that were tied to these interactions or transactions. They were often manual, they were paper-based, there was the potential for fraud. So think about misrepresentation of goods, say in a bill of lading. There was a lack of visibility when you think of all the different members of their business network. So it's a lot more than just ocean carriers. It's third-party logistics, it's supply, trade associations, port authority, importers, exporters, freight forwarders, et cetera. And they also found that there was the potential where if they didn't have the paperwork that was required, that a container could even stay at port, and that could cost thousands of dollars per day. So they were looking at more efficient ways to interact with the members of their business network amongst these multiple organizations. And they worked with IBM on a pilot starting in 2017. And that pilot ended up becoming actually a joint venture, which is called TradeLens. And that venture and that pilot became so successful that now it extends to more than half of the world's ocean container cargo today. So in order to understand why it was successful, we first need to look at how transactions that span multiple organizations are traditionally done and how blockchain provides value. And when we look at how transactions are traditionally done that span multiple organizations, typically, each organization has their own siloed systems of record, and the information which gets written to each of those systems of record for each organization may be slightly different. So if I'm a manufacturer, I'm transacting with a carrier, the information that gets recorded in each of our databases or each of our systems of record may be different. That can lead to potentially disputes, discrepancies. There may be reconciliation that occurs. Remember that we talked about the fact that in many cases, some of these processes, there was manual or paperwork processes as well. So in some cases, the information never even gets recorded to that other organization's system of record. And also the other idea is this idea of a lack of visibility potentially. I can't see what's in organization B's system of record or organization C's system of record. So if I need that greater view, I have to depend on just these different siloed pieces of information and have to reach out potentially to get that. The third idea is this idea that if I have this information in a centralized system of record, well, I can protect it using certainly layers of security or depth and security. And I'm not saying that depth and security isn't a good thing. It's a very good thing. But what I am saying is even with these layers of security, there was still the potential for an unauthorized actor potentially to maybe change something in one of these, or at least we've seen this in some of these siloed systems from time to time. And what's dangerous here is then if you have an organization that is acting on information which may be incorrect or where there was an unauthorized change. So if we look at how this is different when we look at a blockchain, well, you're still going to have your centralized systems of record or your siloed systems of record to some degree, but what you do have is they are augmented by a shared, replicated, distributed ledger which serves as a single source of the truth when these multiple organizations are transacting. So now when a transaction occurs, the information which gets written to one organization's ledger is the same information which gets replicated to the other organization's ledger as well. So now if I'm the manufacturer, if I'm a cargo owner, if I'm an ocean carrier, I'm going to have consistent information and shared information that I'm going to act upon. The second idea is this idea that before that information can even be recorded to the ledger is this idea around consensus. And consensus says that, and there are certainly different definitions around consensus, but in this case, the results of the transaction we have to agree on, or a quorum of members have to agree on. And also the state of the ledger prior to the transaction being executed, we have to have agreement on. So there are certain conditions that we all have to agree upon and we have to sign off on as members of this business network before the information actually gets recorded to the ledger. The third idea is this idea that once this information gets recorded, it's like writing it with a black Sharpie. It's like doing a crossword puzzle in pen. Once that information is there, it cannot be removed. It is immutable in nature. And if anyone tries to modify any of that information, if a single organization or a bad party or a non-authorized actor goes and tries to change that information, the very nature of the blockchain is that for each block, there's a cryptographic hash which gets generated. That hash is based off of the data that you're recording into the ledger, along with a hash from the previous block. And that means that it's easily detectable if someone makes a change to that data, because the hash is no longer going to match, and also because you have all these copies or replicas of the ledger that it's not going to match what those replicas have. So once we have that information, or if someone was potentially going to try to make a change, we could easily detect it and then take the appropriate actions, such as quarantining a specific node if that was the case. So that makes it really good for having an immutable audit trail when you're looking at any type of digitized asset that you're looking to track. So that makes it really good for certain specific use cases where you want the provenance of that specific asset. The last idea I'd like to just jump on really quickly is this idea around smart contracts. And smart contracts are the business rules which get executed on behalf of a transaction. So we have to have agreement amongst the members of the network, again, on the actual smart contracts which actually get implemented and deployed to the network. So we all have to sign off on those, or a certain number of members have to sign off on those pieces as well. So all of these, when you start to add all of these capabilities around a shared replicated ledger, one that can't be tampered with, and having agreement on the specific business rules, and also agreement on the results of the transaction and the state of the ledger before information gets written to the ledger, then what you're doing is you're baking in this trust, this transparency, this traceability into the actual system itself. And that's really what makes blockchain unique and provides these attributes which make it great for very specific use cases. The last piece I just want to mention is that you can have members of your business network which interact with a blockchain infrastructure or with the blockchain, but don't have to host the actual blockchain infrastructure itself. And the reason behind that we'll get into a little bit, but anyone that interacts with these types of blockchains, and the type of blockchain that I'm talking about in this case is a permissioned blockchain network, which means that you have to have the appropriate credentials. In this case, we're using PKI 509 type approach, but you have to have the appropriate identity in order to interact with the blockchain network, and you have to be invited to the blockchain network. So this is a permissioned blockchain network. Identity is important, and that's a key differentiator between some of the other blockchain technologies that you may be aware of. In this case, again, you have to have the appropriate credentials, and that identity is going to determine what data you can touch, what operations potentially you're allowed to execute, and so on. And all of these things are configurable as part of this. So the IBM blockchain network is built off of an open source, open governance technology called Hyperledger Fabric, which is hosted by the Linux Foundation. And the whole idea around Hyperledger Fabric is this permissioned blockchain network, which has certain attributes which make it good for business, good for government, versus maybe some of the concerns that government or business may have that are tied to public blockchains. Not to say that public blockchains don't have certain use cases where they fit, but what we're talking about here is a permissioned blockchain network. I already touched on the other three kind of key areas around permissioned blockchain in this, around smart contracts, again, the business rules which get executed, a shared, replicated, distributed ledger, this idea around consensus. Certainly, there are different algorithms and different approaches to consensus, such as proof of work and proof of stake. You may have heard of miners. The approach that we take with Hyperledger Fabric and with the IBM Blockchain Platform, there are no miners. There's no group in China or somewhere else that's doing any kind of Bitcoin mining. There's no crypto that's involved here. So with that being said, what I'd like to do at this point is I'm going to hand this over to my colleague Tim, and Tim is going to talk about a very interesting use case. So at this point, Tim, go ahead. Hopefully you should be ready to go.
Thanks, Jeff. Hello, everyone. Jeff's been talking about the use of blockchain in the commercial world. It's very understandable, all these parties talking together or working together to ship a container around the world, right? That makes a lot of sense. And that's all possible because of the internet, right? So they all have this common network that they're communicating on it. But let's talk about the DoD world, right? DoD is a very different world. DoD has these things called multiple security domains. How do you work in that kind of environment? For those of you perhaps not familiar with that, this screen illustrates the concept. So at the biggest level, you've got a low side wide area network like the NIPRNet, and you've got a high side wide area network like the SIPRNet. The DoD has all kinds of entities communicating on those different wide area networks, but a lot of the business processes require coordination across both of those domains. Well, how do you do that? And that's been a problem since day one of networking, and to date, the problem still exists. In fact, cross-domain is, I would say, is the big elephant in the room when it comes to the mission space and the DoD. There's essentially no really relevant mission that takes place without crossing one or more security domains. This list here shows just a sampling of some of them at the highest level, starting from at the top, multi-domain command and control. By the very name itself, it recognizes that it's working across domains. Intelligence collection, right, and doing processing, exploitation, dissemination. A lot of times you're dealing with multiple nations in that collection, or you're working with open sources, but a lot of that analysis and aggregation takes place up on the highest classification networks. And I could go through the whole list there, even ones that you wouldn't necessarily think of. Well, how about, IT tickets, right? That's surely not a cross-domain use case. Well, it is, because what they do is all the tickets generated on the low side get sent up to the high side, and at least one command that I know of, and I'm sure it's more extensive than that. Same with cybersecurity. So your SIM-generated events all get moved up to the high side. Anything generated on the NIPRNet gets moved up the high side. So even those things you might not think is a cross-domain use case, it really is. Okay, and then the last one, identity management. Okay, that's a big problem, right? Every domain has their own certificate authority or set of certificate authorities. The external world has their own external certificate authorities. You've got to come up with trust chains to trust someone else's certificate authority. You've got a separate CAT card on each network that you're operating on. It exists everywhere. So what's the traditional solution? Well, you put a guard between those two networks, obviously, right? You put some kind of application level firewall. It's really secure, really locked down to control that exchange of information across it. And what happens is that it's so locked down and so controlled that it's really hard to work with. And there's a lot of kind of shortcomings to it. As you can see, what typically happens, you'll have a big flow going from low to high. So everything gets aggregated up on the high side, and just sometimes by definition, aggregation of data becomes classified. So what they do is they ship everything to the high side. And then there's only a trickle of flow that maybe comes back to the low side. So low side participants are pretty much left in the dark, right? And this low side users can be foreign nations too, right? Like if we're sharing between Canada and the US. Well, okay, yeah, we'll gladly take all your intelligence, Canada, but I don't know how much we're going to share in return, right? It's the same thing, for them too. They'll gladly take as much from the US and they won't share as much in return. That's just the nature of the beast. But the problem, one of the big problems is, so yes, you can securely get the information across, but you really never know where it got to or who's touched it along the way, because the nature of these guards are, in general now, you drop the file into a low side folder, the guard picks it up from that folder, moves it to the high side, and then supposedly someone comes on the high side and picks it out of there, right? But you never really know. That's the whole point, because there is no in-band way to tell where the information ended up. The guard itself is just considered a point-to-point appliance that you plug in, and its only responsibility is getting between these 2 points. So someone on the low side with his unclassified trouble ticket wanted to get up to the high side for the aggregation of all the trouble tickets, sometimes you just really never know unless you get on the phone if it got up there. And I had a client just the other day complaining about that very thing, and these were for IT events, right? System-generated events from the low side, they aggregate them on the high side for analysis, and they're missing some. And that's because of this case. So you don't have that end-to-end visibility. You don't know if both sides are really seeing the same information. And that results in, that's all the problems. Just you don't get very good collaboration and communication in the context of a business process, right? You don't get that common operational picture. You don't have accurate situational awareness of where the process is at any time. It's really hard to coordinate that process and information sharing. And when you get the data, you really can't be, you don't have that much, as much trust as you should in that, because you don't know who's touched it along the way. You don't know if it's been altered. There's just it's a lot of problems with it. So how about this? This is the vision, right? So Jeff was talking about all the controls built into a blockchain, because the underlying purpose of a blockchain is to facilitate assured communication between parties that really don't trust each other, right? Those shipping container people don't trust each other, Inherently, they don't trust each other. Well, a cross-domain network boundary is the ultimate in mistrust, right? You just never, no one on the low side is trusted on the high side and vice versa. That's the whole point of guards, right? But imagine this, a blockchain network seamlessly extending across multiple security domains. Everyone on that blockchain network, because it is a distributed ledger with all those rules for consensus, smart contract, privacy rules, et cetera, all those things controlling it. So everyone in essentially real time sees the same information in their own instance of the ledger. That's the vision, and I believe that's the it's possible. And I'll go into it here in the next slide. I believe it's possible because by nature, the fabric gets you, the open source fabric gets you part of the way there because, again, it was designed to share information in an assured manner between untrustworthy parties. And you can see some examples of the controls that are built into it. And these are the same controls that a guard implements and enforces. But it's not quite enough because it wasn't designed for a multiple security domain use case, right? The DoD is pretty unusual in that sense. So you do need to add on some special sauce to it that provides some additional controls specific to a cross-domain world that prevent identity and content spillage. And you host all this on a high assurance platform, which the bottom layer is what the guard software is hosted on, a high assurance platform, to make sure all those other controls can't be overridden or corrupted. What that does for you, it provides that end-to-end assurance that something that you shared across a domain actually got there. And this particular diagram is showing how it can be used in conjunction with a conventional file transfer guard, because the ledgers themselves, the blockchain ledgers, are not designed or intended to store huge amounts of information. Again, just a conventional paper ledger was never intended for that purpose, right? The ledger is just a single line for each transaction that records just the minimum of information you need to share about that transaction actually happened, right? To who the parties were that were transacting when it happened, and maybe some other supplementing information. But the content, what's being shared, is not included in the ledger. That's going to be set separately. And so a blockchain as a cross-domain solution can also help for this use case. So imagine in this, as the scenario shows here, the blockchain cross-domain guard, the low country, and this is showing an intelligence sharing scenario. Let's say Canada wants to share some information with us. So they put a record that says, we're going to share some photos, intelligence surveillance photos with you, and we're going to share it with you. And they could record that transaction on the ledger. The file, or the photo itself, is accompanying that transaction. It's got a hash of it, so you know that the photo didn't get altered, right? And the hash of that photo will go on the ledger, but not the photo itself. And so that transaction goes, and the blockchain consensus mechanism approves it. Everyone says, oh yeah, it's good to go. And when the blockchain consensus controls and content controls are built into that, says it's okay, then imagine at the commit, it sends a signal. So now it's using as a signaling mechanism to your traditional file control guard, gives it permission, in essence, to send the file across too. So now at the far end, the guy, he's got the identical ledger, so he knows that it was sent, and he knows when he got it, and he can record that he got it. And that ledger information, I don't show that arrow flow, but the ledger, since it's a shared ledger, gets down to the low side as well. So everyone knows now that the United States got this photo that Canada sent it. So you do get that end-to-end assurance now. It also helps in the world of mission partner environments. Today, when a coalition is stood up, and we've got some standing coalitions that just, they're standing, they just stay there, and we've got ones that are more on an ad hoc, short-term basis that get stood up. Well, for each of those, you have to stand up your own network, right? This is the shared network, and we're all going to operate on that. We'll install some software on here, and we'll all be stationed, and using the same thing. Well, for each different coalition, you have to stand up a whole nother mission partner environment group. So you have this proliferation of all these environments. And it doesn't solve the problem, right? Because you might be collaborating within your shared mission partner space, but at the end of the day, you have to phone home to your own country's network. So you still have guards here. So it's still a cross-domain use case. Well, potentially with a blockchain now, and using the capability of channels, you could essentially use the same infrastructure with multiple channels to share between multiple different groups of coalition partners in an assured manner, collapsing and not needing quite so many of those mission partner environments. And the last case that I'll talk about is the identity. Identity, I think, arguably the biggest and most, impactful potential use for blockchain, because it provides a means for assured identity regardless of where you are. And particularly, and this is for self-sovereign identity, which is a whole topic in itself, but blockchain is behind self-sovereign identity. Blockchain is what provides identification registries where your decentralized ID is recorded in a blockchain, so it's secure and it can't be altered, along with information about how to connect and communicate and authenticate to that digital identity. Well, none of the information in that registry is intended to be private. It's supposed to be like a yellow pages, white pages where you can search, make it searchable. But the controls come in when you look up that person's address. It says, well, if you want to talk to me, you have to go to this endpoint and be prepared to show this kind of credential if you want to talk to me. That's what's in that registry, nothing else. So that lends itself very well to having a single identity network across the DoD that contains all that kind of information, right? So now you have that assurance, and along up in that registry is also your public key. So when these two clients, and down here it explains it, you got two client apps that want to talk to each other. What they do first is they establish an SSL connection. With that at the network layer, that's good. It tells the two boxes that you're talking to are the two boxes. But how do I know that the person behind that box that's on that box is really who it is? That's the level where DID comes in. So now you know that Tom Smith is on this box and Bob Jones is on this box. And they know that because what they do is they exchange their DIDs. Each one goes out to the identity network, looks up that DID, gets the public key. They can authenticate each other. Now, not only at the network connection layer, but at the application layer, they have mutual authentication. They know who they are. They can talk to each other in a trusted manner. So again, the concept is blockchain, in the ultimate case of not trusting each other, is in a cross-domain scenario. Essentially, every significant mission use case in the DoD involves cross-domain. So a blockchain could add a lot of value here with seamless networks that span any of those existing stovepipes due to classification, countries and organizations, et cetera, and provide that common operational picture, the shared situational awareness, and trust in the data. And there's plenty I believe these slides will be made available, but there's plenty of additional reading for you on these topics. And with that, I'll turn it back to you, Jeff.
Thank you. Thank you so much, Tim. Okay, so what we're going to do now is we're going to kind of switch gears just a little bit, and we're going to talk about the IBM Blockchain Platform. So as I mentioned earlier, the IBM Blockchain Platform is built on top of a technology which is open source and open governance called the Hyperledger Fabric. And the IBM Blockchain Platform and this capability can run pretty much anywhere that your containerized applications or Kubernetes environment can run. So that means we can go and we can run it both on-premise, or we can run it in any cloud that supports most Kubernetes environments. And we'll talk a little bit more about that. So we provide it as both as a blockchain as a service or as software. Now, where does IBM Blockchain Platform provide value? Well, the first is we want to, again, the whole idea around vendor lock-in, we want to stay away from that. IBM really is all about open source and open governance these days. But what we do is we provide additional value when it comes to both the tools to build out your network, to build out your smart contracts, develop those networks and those smart contracts, and also around the operations piece, the maintenance. How do you update your environment? How do you do the governance and policy that is so important when you're looking at that blockchain network? all of those pieces there, we make it much simpler to do so and provide you with powerful tools that allow you to do that. And again, in such a way that we have an environment which will run pretty much in any, again, containerized environment. So case in point, whether it's Amazon, AWS, Azure, behind your firewalls, or running in any of our IBM clouds, we can do those things. And the platform itself is optimized to run, besides the fact that in Kubernetes, but specifically we're providing capabilities around Red Hat OpenShift. So certainly, for those of you that are familiar with OpenShift, it's Red Hat's Kubernetes platform. What we do is we provide specific capabilities, whether it's around automation, standing up your environment using Ansible scripts, being able to add additional components and also leverage the baked-in security that the OpenShift environment provides. So things like support for FIPS 140-2, crypto, all of those pieces there, those are the kinds of things that we're providing. And also what's really important to remember is that when you stand up a blockchain solution or a network, it's never just the blockchain. Certainly, just like when you stand up a solution that uses a database, it's never just the database. There are other components and capabilities that you always have to think about when building out a network and making something real, whether it's integration with existing systems, integration with your security environment, whether it's providing resiliency, all of those things. And this is where that synergy really comes into play, and where, again, we're providing these additional capabilities. And we do so, again, where you can deploy it in different environments and trying to avoid vendor lock-in. So I just want to do next is I'd like to kind of take you through a quick demo. One of the largest IBM networks or blockchain networks that is out there today is something called the IBM Food Trust Network. It started out with Walmart. It's Walmart, it's Kroger, it's Unilever, it's Nestle's, I believe Tyson, Smithfield. They were all members of this network. And the whole idea around the network is around, again, providing traceability, providing provenance when it comes to tracking your food from farm to table. And all of the different pieces there. We can do the same thing, obviously, whether if you're working with geospatial intelligence or other items as well. Again, so think of that when we're kind of taking you through this demo. So this, hopefully you can see my screen, is just the home page for our IBM Food Trust Network. Just a basic dashboard with some basic information for a fictitious organization in this case. What I'm going to do is I'm going to take you to our trace module, where you can actually start to trace and say, okay, if I have some product that I want to trace, in this case, we're going to trace, oh gosh, we're going to trace some baby food. If I can get to my screen here. There we go. All righty. So I'm just going to get the product ID, and I'm going to pop it in here. Oops, I got the wrong one. Let me get the right one. All right. And, okay, so in this case, we're going to trace, this is baby food. Good for babies. Backyard veggies is the product. We'll use that as the product. And now we'll just type in a lot number in this case. And once we do that, we're going to go and start our trace. And when we start our trace, what you're going to see is you're going to see all of the different touch points that were tied to that baby food. As it continues to work through the trace, notice here we can see the stores. So if there was some sort of a recall, if there was a problem with contamination or something along those lines, and we want to be able to selectively recall or understand, who has actually seen this information, we can do so. We can expand, we can look at the store information. I can drill down, get the address of the store, get potentially the lot number and the purchase order that was tied to it, the date, etc. I also can go and I can look at who were the distributors potentially that were tied to this lot of baby food. So again, which facilities have touched this, potentially to understand potentially where the contamination may have come, where it came from, the manufacturing plant, the processing plant, what were the different pieces, or even all the way down to the farm. I can get that information and look at the farm information regarding the apples, the lot, the packing. All of that information is at my fingertips. And I have different views as well. I have the supply chain view along with the timeline, or I can drill down into a product view and I can see, okay, here are the different ingredients that went into that baby food, and as the byproducts from the initial product, how we got to the ultimately to the baby food. But you can see the different pieces there. Again, now you start to see and understand how this can be used for provenance, for tracking items, etc., and providing that visibility that I might not necessarily have in the past when working with a blockchain. Of course, there are other areas to think of besides the traceability aspects. Certainly, as Tim mentioned, there's how do I share documents like safety certificates or things along those lines. So again, leveraging the blockchain is part of that solution, but not the entire solution. So being able to go and look at a specific certificate that was tied to a member of my supply chain. Or potentially, if I want to look at some of the other areas of interest, what are the different products that I'm tracking as part of the supply chain? What are the facilities that are members of my supply chain? And probably one of the most interesting ideas around the blockchain is, again, the governance and policy. So understanding what are the different policies that I can utilize potentially and work with to specify whether or not I'm going to do something where I'm going to share maybe information with all members of my supply chain, or maybe this is only information that I'm going to share as part of a handoff. In this case, maybe a one-up, one-down type of transparency approach. So these are some of the key capabilities and some of the ideas that we can use by leveraging a blockchain network. Now, the other thing that I wanted to touch on really briefly was this idea around, well, we also have this capability when it comes to our development tooling. Again, a way to work with common tools like VS Code to provide capabilities that make it easier for us to go and work with blockchain solutions. So whether it's, again, using a test harness, standing up just a real quick sample network that I can work with, in this case, as I'm driving transactions and testing those transactions as well. So in this case, I'm connected to a real blockchain network in this case, using a specific ID, using a wallet, which has my credentials, again, the PKI credentials. And now we can start to do interesting things. I can test some of my transactions here. So in this case, I have a digitized asset being a car. I can go and I can say, all right, let me submit this transaction where I'm going to change the owner of the car. So I can go in and, let's see, enter the car identifier along with, let's see, I lost my car to Tim in a poker game. So now I'm going to make him the owner of the car. Now, what's going to be interesting here is I'm going to go, and there are different, remember, we have governance and policy, and when it comes to even consensus, who are the members of the network that have to sign off on it? Let's say that in this case, normally I have both, this is a very small test network, I have both my organizations have to sign off it, but let's say I only have one member in this case instead of both. And now if I try to submit my transaction and I click OK, it's going to run, it's going to try to go through consensus. But notice here we get an error. So what we have here is we have an error where we have an endorsement policy error because we don't have the appropriate members of the network endorsing and signing off on the transaction. Now, again, if I go and I run the same transaction, and I go in here and I just put in again, Tim, I'm going to give you that car I owe you, I promise, right? So go to Tim. I'm not going to provide any transient data. In this case, I'm going to use the default, which is to have both the peers or both the nodes have to sign off on this. And this time now, notice our transactions was successfully submitted, and we have a result here submitting the transaction. Now what we can do is we can actually go to my running blockchain network in this case. And if I refresh my screen, I should hopefully see a new block that was loaded. Whoops, got to get back in here. My apologies. But if I go to my channel and my chain, and my block history, now we see at 2:41, a transaction occurred. And if we look at that transaction, we'll see change car owner with Tim, and now he is the proud owner of a blue Subaru Outback. So you can kind of see how we're providing these capabilities that allow both developers to work with the network. There are other capabilities around governance and policy, defining your network, some of those pieces of the automation. So I just want to kind of give you a really quick tour there, or at least a little bit of flavor around some of the capabilities that are there. What I'm going to do now is I'm just going to finish up with a couple of slides, and then we'll see if we can jump back to some questions. And I went too far, so let me get through Tim's slides. And okay, so the last 2 points that I wanted to make were, first, again, that this is real. IBM Blockchain Platform, built on top of the Hyperledger Foundation project, excuse me. Hyperledger, again, being managed by the Linux Foundation. We have 200 plus members. You can see from all different groups in industry and government. So Accenture, IBM, Intel, JP Morgan, American Express, certainly Lenovo, Red Hat, the list goes on, State Farm, Splunk, Oracle. They're all members here of this foundation project. The Hyperledger Steering Committee is led by an IBMer, but certainly there are a lot of other organizations that are participating to this. I should also mention that as part of the IBM Blockchain Platform, we provide support. If you just want to use the Hyperledger Fabric pieces, and just only even Hyperledger Fabric pieces, again, we provide support and will patch and fix any, if there are any problems that are discovered with Hyperledger Fabric as part of the IBM Blockchain Platform, we will do so. The other two, I guess the other thing I want to point out is there are lots of blockchain networks that are out there and in production today that we're standing up as within IBM. So I mentioned the IBM Food Trust Network, where we've got Walmart, Golden State Foods, Nestle's, Kroger, Smithfield, Driscoll, Dole, Carrefour, others that are members of that network. Certainly with TradeLens, again, over 50% of the world's ocean cargo now participating in that network. WeTrade is another big network. This is to facilitate cross-border trade for small and medium enterprises, with some of Europe's largest banks are part of this network. And the list goes on and on. We recently completed a pilot with the FDA around tracking pharmaceuticals. So certainly, you know, there are other areas within government I should mention. So, whoops. So in DoD, we finished up a pilot recently, but we're working with US Indo-PACOM around the Intergovernmental Personnel Act. So being able to kind of track that process with onboarding a contractor or a contractor or an out-of-government hire and bringing them in because they have a specific skill, and providing greater visibility and auditability into that process. US Postal Service, a really big project that we've been working on since 2017 around tracking international mail, where US Postal Service is working with commercial air carriers, providing greater visibility into mail receptacles that ultimately get delivered to the foreign post. And another really exciting area that we're working on is we're working with DISA on providing blockchain as a service. So they're standing up the environment and then allowing us to bring in mission partners into this environment, and we're working on the accreditation process today. So really excited about where we're going in this space. Every use case is different, very interesting. We're thrilled to get to work with ESS and hopefully work together on some solutions or some projects moving forward. And at this point, I'd just like to open it up to some questions, and thank you for listening.
Oh, thanks, Jeff, and thanks, Tim, for all of that great information. We have not had any questions, Tim, Jeff, so I think we've stunned them into silence.
I am happy. Just any conversation anywhere that you guys want to kind of talk about. Certainly in this space, this is really an exciting area for us. Every use case is different. We get to learn something new. I've worked on everything from especially around food. So imagine dealing with meat and export certificates there. I learned things about every use case is so different. I learned something new about a different industry that I wouldn't have learned about if I hadn't been in blockchain. So it's a really exciting space. I certainly am thankful for Tim for his expertise, especially when it comes to cross-domain and DoD, and likewise to Bill, because that's definitely not my domain. But if I can't answer any questions, I'm more than happy to do so.
All right, thank you. And for, I guess, people that are out there listening, last time we talked a little bit about the cross-domain that we were working on. And that's part of a project that we're working here with IBM. So I'll take back the video. And then, of course, we do have other projects we're working on as well. Geospatial, the the SCADA potentials. Oh, I'm starting to see some questions here. Hold on. So we got one that says, does the data grow exponentially as transactions are added?
So, I don't think the data grows necessarily exponentially, but I think you bring up a really good point, which is you have to be careful regarding how, what data you put on the blockchain. I think Tim really kind of alluded to that as well. It's not built or made for putting, large data on the blockchain. The other thing that I'll mention also is we recognize this as one of the key challenges in blockchain in general. So the Hyperledger Fabric team, if you look at their roadmap, is specifically working on the ability to do checkpoints for Hyperledger Fabric so that you can start to address some of the challenges as you continue to put data onto a blockchain. Now, there are other ways that you can kind of get around this with Hyperledger Fabric, which is tied to creating new channels and moving data from there. There's one of the key capabilities that Hyperledger Fabric provides is around an event listener, where you can kind of take data and information and do things that way. But that's kind of a bit of a duct tape solution. So they are actively working, and as part of the roadmap for Hyperledger Fabric is to address that specific challenge that's tied to data growth on the blockchain. Hopefully that answers that question. The other question I see is around how many government agencies have already approved this platform on their own internal networks. And that is really a key challenge. So we've done certainly work, and Hyperledger Fabric specifically has an ATO, for instance, with HHS, Health and Human Services. Other agencies have done this, and DoD has done this for pilots. But as in regards to ATOs, we're still early. That's, again, one of the areas we're working on with DISA. So as we move towards hopefully more production, we'll see more approval on this specific platform. I also wanted to address that there is an article out there somewhere which kind of talks about Hyperledger Fabric specifically, and saying that the crypto for Hyperledger Fabric does not meet specific criteria. And the authors that wrote that did not necessarily look at all of the solutions that were tied to Hyperledger Fabric. So the first thing I'm going to say is that the IBM Blockchain Platform specifically does, at least for x86, use FIPS 140-2 crypto. It uses a Google crypto implementation for that, and we're actually, the recommended solution when you go into production is to use a hardware security module for the crypto in this case. And so if you're using that hardware security module for those crypto pieces, then really, again, that's providing that piece there. So I wanted to kind of make sure I addressed that as well. Let's see. In addition to federal and DoD efforts, are you working with the IC Fort Meade? Can you speak to those efforts?
You want me to take that one, Jeff?
Yes, I do. Thank you, sir.
All right. So yes, we are working with them. We do have multiple inroads at the moment. The IBM platform, the blockchain platform, has been approved for use on one of the internal systems. They're working on standing that up now. Once that is stood up, we will start looking at developing some blockchain solutions for a couple of our current customers. That depends on how much the COVID craziness gets in the way of progress on standing up the IBM blockchain platform, as well as getting into the individual development projects.
Thank you.
Sure.
Any other questions? I will say that I am happy to work with Bill and the ESS team. If folks want to drill down deeper into any of these topics, certainly I don't want to speak for Bill, but I know that we're certainly always excited to have follow-on conversations and talk more about any of the subject matter that we're covering here.
All right, great. For everybody that's listening, keep in mind too that we have another webinar in 2 weeks where Oracle will present on the Oracle blockchain platform. Then 2 weeks after that, we will have me speaking again on the open source blockchain alternatives and the development that you can use, go through with the open source options. We will hang out for a minute or so more in case a couple more questions pop up. But otherwise, thank you all for attending. Thanks to Jeff and Tim for their time. All right, I think we're gonna call it at that. We don't see anything more coming across the questions and answers. If you guys have time, please go ahead and fill out the poll. And then thank you for coming. We'll talk to you next time in 2 weeks. All right,
Bill,
thanks,
thank you.
everybody.
Thank you so much.